Alright, so in this problem, I have x to the power of x to the power of 5 is equal to 100. So now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, I can actually change the place of these two. So this is going to equal a to the power of n times m. Now, if I have something in the form a to the power of m times n, and we can write that as a to the power of m to the power of n, this means that I can write a to the power of n times m as a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 5 to the power of 5, and I can think of x to the power of 5 as m and 5 as n. So now if I switch these two places, I get x to the power of 5 to the power of x to the power of 5. And this is equal to 100 to the power of 5. Now 100, that's the same thing as 10 to the power of 2. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 2 to the power of 5. Now remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, that's equal to 10 to the power of 2 times 5, which is 10 to the power of 10. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 10. Now, I'm going to let x to the power of 5 equal to the variable y. So now I have y to the power of y is equal to 10 to the power of 10. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 10. Now remember how we set y equal to x to the power of 5. So this means that x to the power of 5 is equal to 10. So now to solve this, I'm going to take the fifth root on both sides. So now I have fifth root of x to the power of 5 is equal to the fifth root of 10. So the fifth root of x to the power of 5, that's simply equal to x, and x is equal to the fifth root of 10, and this can also be written as 10 to the power of 1 over 5. So this is my answer. Alright, so in this problem, I have 20 to the power of 40 over 40 to the power of 20. So to start, I'm going to rewrite 20 here as 2 times 10. So I have 2 times 10 to the power of 40 over 40, I'm going to rewrite as 4 times 10. So over 4 times 10 to the power of 20. So now, if I have something in the form a times b to the power of m, this is equal to a to the power of m times b to the power of m. So in this case, 2 times 10 to the power of 40, I can rewrite as 2 to the power of 40 times 10 to the power of 40. And 4 times 10 to the power of 20, I can write as 4 to the power of 20 times 10 to the power of 20. So now I have 2 to the power of 40 times 10 to the power of 40 over 4 to the power of 20 times 10 to the power of 20. So now, this is the same thing as 2 to the power of 40 times 10 to the power of 40 over 4. This is the same thing as 2 squared. So over 2 squared to the power of 40 times 10 to the power of 20. Or sorry, this is not 40, this is 20. So times 10 to the power of 20. And now this is the same thing as 2 to the power of 40 times 10 to the power of 40 over 2 to the power of 40 times 10 to the power of 20, because 2 times 20 is 40. Now, as you can see, we have 2 to the power of 40s, one in our numerator, one in our denominator, so these two can simply cancel out. So now I'm simply left with 10 to the power of 40 over 10 to the power of 20. Now, 10 to the power of 40, this is the same thing as 10 to the power of 20 plus 20. So now I have 10 to the power of 20 plus 20 over 10 to the power of 20. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 10 to the power of 20 plus 20, that's going to equal 10 to the power of 20 times 10 to the power of 20. And I have this over 10 to the power of 20. So now these two 10 to the power of 20s can cancel out. So now I'll simply be left with 10 to the power of 20. So this is my answer. Alright, so in this problem, I have 6 to the power of 100 minus 6 to the power of 97. So, now the first thing I'm going to do is I'm going to rewrite 100 here as 97 plus 3. So now I have 6 to the power of 97 plus 3 minus 6 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m a to the power of m times a to the power of n. So in this case, 6 to the power of 97 plus 3, I can rewrite as 6 to the power of 97 times 6 to the power of 3. Now I have this minus 6 to the power of 97. Now from here, if I factor out 6 to the power of 97, I get 6 to the power of 97 times, now 6 to the power of 97 divided by 6 to the power of 97, 6 to the power of 97 times 6 to the power of 3 divided by 6 to the power of 97, all that's going to be left is 6 to the power of 3, and negative 6 to the power of 97 divided by 6 to the power of 97 is negative 1. So I have 6 to the power of 97 times 6 to the power of 3 minus 1. And now 6 to the power of 3, well, 6 to the power of 2, that's equal to 36, and 36 times 6, that's equal to 216. So I have 6 to the power of 97 times 216 minus 1. And 216 minus 1, that's equal to 215. So now I have 6 to the power of 97 times 215. So my answer is 6 to the power of 97 times 215. Now I actually have a second method of solving this problem. So I start with 6 to the power of 100 minus 6 to the power of 97. Now this time, instead of rewriting 100 as 97 plus 3, I'm going to rewrite 97 as 100 minus 3. So now I have 6 to the power of 100 minus 6 to the power of 100 minus 3. Now I'm going to rewrite 100 minus 3 as 100 plus negative 3. So now this is going to be the same thing as 6 to the power of 100 times 6 to the power of negative 3. Now from here, if I factor out 6 to the power of 100, I get 6 to the power of 100 times 1 minus 6 to the power of negative 3. And 6 to the power of negative 3, that's the same thing as 1 over 6 to the power of 3. Now remember, 6 to the power of 3, that's going to equal 216. So now I have 6 to the power of 100 times 1 minus 1 over 216. And 1 minus 1 over 216, that's equal to 215 over 216. So 6 to the power of 100 times 215 over 216 is another way to write our answer. Alright, so in this video, I'm going to solve the equation 8 to the power of x is equal to 32. So to solve this, I'm going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 32. And now if I have something in the form log of a to the power of b, I can move this exponent b to the front of the logarithm. So this is turned into b times log a. So log a to the power of b is equal to b times log a. So now in the case of log 8 to the power of x, we can think of x as b, so we can move x to the front of the logarithm. So I get x times log of 8 is equal to log of 32. Now, from here, I'm going to divide both sides by log 8 because we want to isolate x, because that's what we're trying to find the value of. So now these two cancel out, and I get x is equal to log of 32 over log of 8. Now, log of 32 is the same thing as log of 8 times 4. So I get log of 8 times 4 over log of 32. And if I have something in the form log of a times b, this is equal to log a plus log b. So in this case, this is going to equal log of 8 plus log of 4, and I have this over log of 32. Sorry, I have this over log of 8. Now, this turns into log 8 over log 8 plus log 4 over log 8. So now these two cancel out to get 1. So I get x is equal to 1 plus log of 4 over log of 8. Now, log of 4 is the same thing as log of 2 squared. And log of 8 is the same thing as log of 2 to the power of 3. So now if I have something in the form log of a to the power of b, again, I can move b to the front, so it's b times log a. So that's exactly what I'm going to do with both of these. So I get x is equal to 1 plus, I can move the 2 to the front. So 2 times log 2 over the same thing with 3, so 3 times log 2. So now these two cancel out, and I get x is equal to 1 plus 2 over 3, which is equal to 1 is the same thing as 3 over 3, so 3 over 3 plus 2 over 3, which is 5 over 3. So x is 5 over 3. Now, how do we know that this is the right answer? So, going back, we have a to the power of x equals 32. And we're plugging in 5 over 3. So we get 8 to the power of 5 over 3 is equal to 32. Now, if you already know, 8 is the same thing as 2 to the power of 3. So I get 2 to the power of 3 to the power of 5 over 3 is equal to 33 is the same thing. 32 is the same thing as 2 to the power of 5. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So these two 3's cancel out, and I get 2 to the power of 5 is equal to 2 to the power of 5, or this is the same thing as 32 is equal to 32. This is right. Now, I also have a second method of solving this problem. So for the second method, we have the same equation, a to the power of x is equal to 32, and this is a simpler method. So for this method, I'm actually just going to start by rewriting these two numbers. So 8, I'm going to rewrite as 2 to the power of 3. And 32, I'm going to rewrite as 2 to the power of 5. So I'm rewriting both of these as these same bases, which now it makes them much easier to solve. 2 to the power of 3 to the power of x is the same thing as 2 to the power of 3x, which is equal to 2 to the power of 5. And because these two have the same bases, a to the power of m is equal to a to the power of n, meaning m is equal to n. So 3x is equal to 5, and x is equal to 5 over 3. So that's another method of solving this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.